Hi everyone, my name is Max, Developer Advocate at Digital Asset. We will be going over one of Canton's most important features, Subtransaction Privacy. This is built in natively to the protocol, and no other distributed ledger technology provider can do this at the moment. If you don't know what Canton is yet, I've linked some resources below. So what is Subtransaction Privacy? Let's take a look at this example. Person A buys a widget from a shop. The subtransactions resulting from this are three workflows. The shop transfers the widget to A, the shop creates a receipt for A, and the bank transfers money from A to the shop. These are subtransactions, and all subtransactions should happen atomically, meaning they all happen at the same time, and they either all happen or nothing happens. The privacy here means that only person A in the shop should know the details of the transaction. The bank should know nothing because it doesn't concern them. All the bank should be responsible for is to transfer the cash. In order to fully appreciate and understand the value of subtransaction privacy, let's go through a few examples. Let's take a look at the following example of an insurance claim workflow. This is an example of a delivery versus payment flow that involves multiple parties. In today's architecture setup, without the concept of subtransactions or even distributed ledgers, it resembles something like this. On the bottom left, we have a clinic. At the top, we have an insurance provider. And at the bottom right, we have a bank. They all have their own databases since they're separate entities. Today, when I finish a procedure at the clinic and pay my fee at the payment gateway, what happens is I'm giving the bank authority to transfer balance from my bank account to the clinic's account. Upon confirmation from the bank, the clinic then gives me a receipt and saves the transaction into their database, and a record is created. Next, I go to the insurance provider, upload the receipt to their system, and now we can see there are two instances of a record. The insurance provider then checks with the clinic whether the receipt is valid. This process is called reconciliation. Reconciliation is an expensive process because it's a time-consuming, manual process that can be prone to errors. Reconciliation errors are costly and plague entire financial systems. This is the reason why distributed ledgers were invented in the first place. Finally, the insurance company informs the bank to transfer the balance to my bank account, and now I'm fully reimbursed for the procedure I've just done. It's also worth noting that this is a simplified example. This assumes that the clinic and the user are with the same bank, but in reality, multiple banks may be involved, which introduces additional reconciliation requirements. In today's model, without the use of distributed ledger solutions, privacy is taken care of. You can see each entity has their own database. Workflows are also separate and sequential, meaning they aren't atomic. Each entity is coordinating with each other in some sort of manual, sequential way. There is the issue of reconciliation, but also who manages the source of truth? Is it the clinic? Is it the insurance company? These are all issues that distributed ledgers try to address. Now, what if all entities decide to use one database? It seems like things would be more efficient, right? You don't need to upload a separate receipt to the insurance provider because they already have access to this record and can just tell the bank what to do. But this violates data protection and privacy. Your patient records should not be disclosed to anyone, and the clinic should not know how much money is sitting in your bank account either. And that's why even though distributed ledgers can help solve the issue of reconciliation, enterprises have been slow to adopt due to data leakage or the lack of subtransaction privacy. Here we have another delivery versus payment example, but this time let's see how it should look when we have subtransaction privacy. Let's consider a transaction where Alice buys some shares from Bob. In the real world, such a transaction would not be between two individuals, and it would involve numerous intermediaries. But for the sake of simplicity, let's assume that this is a transaction between two people, and it only involves a bank that facilitates transfer of cash and a share registry that facilitates transfer of share ownership, and no other intermediaries. Alice transfers Bob $100. The registry then transfers the shares from Bob to Alice. These two subtransactions are happening at the same time. They're atomic. In addition, the registry shouldn't know how much money either of them have in the bank. All the registry should know is that it should be transferring the ownership, and all the bank should know is that it's transferring the balance. There can't be any data leakage between the bank and the share registry. The ability to maintain privacy of the data, which spans across privacy sets, is what we call subtransaction privacy. Now that we've gone through two examples to see why subtransaction privacy is necessary, let's understand how other distributed ledger solutions aren't able to provide the level of privacy that Canton can provide. If we were to use Ethereum, you can see all nodes have access to the same ledger. Ethereum tackles the issue with reconciliation very well because all nodes have a copy of the record. However, privacy is lost. This is not a solution for organizations that need strong privacy agreements. With other blockchain solutions, such as Corda or Fabric, their transactions don't preserve privacy either. So looking on the right side, everyone in the transaction can see all components of that transaction. So even though the blockchain might be permissioned, stakeholders in a contract can still see everything. So if we look back to this DVP example, on the left-hand side, the subtransaction privacy can be achieved with Canton, while on the right-hand side, everyone has a view of the components of that transaction. To summarize, when data is often used in conjunction with workflows that span across users and applications, the privacy of this information must not be leaked in these composed workflows. The composed workflows and the privacy of the information is what we want to guarantee. Finally, for additional resources, you can visit the Daml community to ask any questions that you might have, or go to the docs and read and get started on Daml and Canton. Thank you.